Alright, so far we have looked at simplifying rational expressions and multiplying and dividing them. Okay, most of that just simply involved factoring and canceling. That will not necessarily be the case here for adding and subtracting rational expressions, because adding and subtracting fractions works differently. So let's look at just a quick numerical example of, let's go with 1/2 plus 3/5. We can't just simply add the 1 and the 3, the 2 and the 5, unfortunately. When we're adding fractions, we need a common denominator. So we will have to multiply the first fraction by 5/5 and the second one by 2/2. This will get our denominators to match at the least common multiple of 10. Now add your 5 and your 6 and leave your common denominator alone. We can't simplify the fractions, so we are just done. Alright, that's really it for adding and subtracting fractions. Okay, the key is you need to get them to match, and you want to get them to match at the least common multiple if possible. For example, if I had 1/2 plus 3/4, I could get those to match at eighths, but that's probably going to leave me a little extra canceling and simplifying work to do in the end. I'd rather get them to match at fourths by multiplying by 2/2. Okay? Alright, now let's take a look at what this will look like when we have variables involved. So when variables are involved, what we want to do is we need to figure out what the least common multiple of the denominators is. So that's what our whole last lesson was about, was finding the least common multiple. So what is the least common multiple of A and B? Well, it needs an A and a B, so it's going to be AB. If I want my the least common multiple, is what, this is going to be our common denominator. So we need to get both denominators to be that. So if we want our first denominator to be AB, we need to multiply by just a B. Second one will multiply by A. And we get 2B over AB plus 3A over AB. Here's where people have trouble. In that first fraction, it just looks so pretty. Let's just cancel the B's. Okay, we can't cancel the B's, because if we cancel the B's, we're going to lose our common denominator. You have to understand that, like if you look back up at that original example, after you multiply in, you actually have a fraction that could very easily be simplified. But don't simplify it, otherwise you lose the common denominator. Simply add numerator and denominator together and put it all over the common denominator. Now you've got one fraction. Now you should see if you can combine any like terms or simplify at all. You can't, so we're just done. Okay, try the next one on your own. Try the next one on your own, pause, and then come back. It's similar to this one. Alright, hopefully you gave that one a try. So here, our least common multiple of 7m and 2m is 14m. We don't need an extra m in there. That's key. Okay, so we're just going to multiply the first one by 2/2 and the second one by 7/7. We're going to rewrite those fractions. We're going to add our numerators to each other and leave our denominators the same. 8 plus 21 is 29. Denominator's 14m, nothing can simplify, we're good. Try the next one on your own as well. The big key here is that those are in parentheses. That's important for when you're getting a common denominator. Okay, so try that one, pause, and then come back. Alrighty, I'm going to go out on a limb and assume that you have done that now. So our common denominator, or least common multiple of 6 and 8, we should be able to do this one without too much effort. That's 24. Okay, so we're going to multiply the first one by 4/4 and the second one by 3 over 3. And again, the key is distribute that 4 and distribute that 3. So we get 4p plus 8, and we get 3p minus 9. Again, we can assume that these things are still in parentheses, but that would really only be important if we had a minus sign in the middle, okay? Because that would mean we would need to make sure that we were distributing the subtraction sign. In this case, we don't need to do that. We just add. We get 7p minus 1 all over 24. Okay, those were all fairly easy, fairly straightforward examples. Now let's get into some ones that maybe are just a little bit trickier. Okay. Let's try D, E, and F. Okay, again, the key is getting that common denominator. D, they already have one. Okay, you didn't need to do anything. They already have a common denominator, so we're going to skip that step and just move right on into x minus y over 3x minus 3y. Here's where a lot of people stop. But we should be looking for opportunities to simplify. So if I just gave you that fraction and told you to simplify, think for a second, pause if needed, what would you do? Well, hopefully you'd realize we need to factor before we cancel, and our denominator has a GCF of 3. If we factor out that GCF of 3, our x minus y's cancel, and we're left with 1/3. What's really interesting is that if you plug in pretty much any numbers for x and y, you will get 1/3. There's a couple of exceptions where this won't quite work, but those are situations in which x and y are the same. That's something for you to think about. Okay, if we get 1/3, you would think, well, then we should always get 1/3 no matter what we plug in for x and what we plug in for y. But if x is equal to y, this doesn't work. That might be something for you to think about and talk about in your groups, but it's not something we'll discuss directly until a little bit later this chapter. Okay, E, let's take a look at that one. Here, our least common multiple of our denominator is x minus 1 times x plus 5. There's no creative way to put those together because remember, when it's addition and subtraction in the middle, we kind of got to put it in parentheses and treat that like one thing. So we're going to multiply the first one by x plus 5 in our numerator and denominator, and the second one by x minus 1. Distribute the x, we get x squared plus 5x. And I'm not going to multiply out our denominator because in the end, if there's any simplifying to be done, I'm going to really want to know if it cancels, and if I want to know if it cancels, I have to have things in a factored form. Okay, now, subtract and combine like terms. The key is, even though you've distributed the 3, this is still in parentheses, its own set of parentheses, because it's on the top of a fraction. So you're kind of distributing that negative. So you're going to be doing minus 3x, but then plus 3, because it's minus negative 3. So we're going to get x squared still. 5x minus 3x is 2x. And we're subtracting, we're doing 0, because we have nothing to match up with the 3 over here. Minus negative 3, that's just going to be a plus 3. Now you have to ask yourself, does our numerator factor at all? It does not. So since it doesn't factor, we're not going to get anything to cancel. So that's just our final answer. Now, if the numerator factored and had used a minus 1 there in any way, then, you know, like a x minus 1 or an x plus 5, then we could have canceled those things out. Okay, last one. I'm going to have you try this one on your own, pause, and then come back. All right, our common denominator is x minus 1 times x minus 3. So I'm going to multiply the first one by x minus 3 and the second one by x minus 1. Again, in numerator and denominator. You're going to have to multiply those binomials together. Okay, you can use FOIL or double distributive property, however you multiply binomials. When we do that, we get x squared minus 9x plus 18. In the second one, we get x squared minus 10x plus 9. and both of these are over x minus 1, x minus 3. Okay, again, the key is subtraction is outside parentheses, so we're going to be subtracting. So we do x squared minus x squared, that's 0. Then we do negative 9x minus negative 10x, that's just a regular x. And then we do 18 minus 9, that's 9. So we get x plus 9 on top over x minus 1, x minus 3. Again, nothing canceled here after we were done, but let me just show you this. If this was a 3, let's go with a minus 3. Again, this is an if, it's not, but if it was, we would be able to cancel the x minus 3's and write it as 1 over x minus 1. Okay, so that's just something to be aware of. You can't always cancel in the end, but that is something to watch out for.